Okay, now comes the assignment of the boundary condition. So it's a very important step in order to get the correct results, of course. So go in the boundary, click on define the supports, and here we have to choose the right group name to assign a whole boundary. Choose the select single, and we'll select actually the node 21. So using select single, you can select only one node, check the D-all and click on apply. Now we'll select three different nodes, the node 1, the node 47 and 67, and this time we will fix dy and dz only. Click on apply. Now we will select the node 2, 48 and 68, and we'll fix only dz this time. And finally the node 22 will be fixed, so dx and dz, and click on apply. Now we'll enter the effective weights. So it is the scale factor which will be applied for the moment of inertia of the girder section. So actually it will be used for calculating the member stress. So if you want to keep the boundary on to see what is going, you have to click on display, boundary, and check the supports. Click on OK. Now activate the node number and element numbers. You can unactivate the nodes. Okay. Now go again in the boundary tab, and this time you have to go in effective weights. Where is it? Effective weights. Now again, don't forget to select the boundary group name. So first for the weights 1. So for the selection we can directly use here this, so 1 to 16, enter. So it selected automatically the elements, and enter the coefficient here, the scale factor 0.985, and click on apply. Now we'll select the next boundary group, weights 2. We'll select the following node 12 to 26. This time the scale factor will be 0.965, and click on apply. Finally, the last scale factor is weights 3. Selection will be, oh okay, I forgot, check again weights 2, and we'll assign to another, so 27 to 40, these elements at the middle, and the coefficient is 0.992. Click on apply, and this time we'll go to weights 3, select 41 to 50, enter. The factor is 0.965, click on apply, and the last one, 51 to 66, enter, and 0.985, and click on apply. Now we'll define the loads. So here you have in this table the input loading data for the right girder, the left girder, for the pre-composite load and the post-composite load. So let's go first in the loads tab, and in the static loads, click on static load cases, enter the name DLBC1. For the load type, choose construction stage load, click on add, and we'll use create several like that, BC3, BC4, and finally AC, and click on close. Now let's assign the dead loads for the pre-composite section. Click on element. You can go in the ISO view and unselect the node number. First, before assigning the element, we'll assign the self weight. So a self weight will be applied during the first case, DLBC1. So just enter -1 in Z coordinate, click on add, click on close. Now you can open element again. Now to select the section, you can go in element here, select directly some section 1, for example, click on add, and it okay. Now it seems that I forgot to assign the crossbeam to the crossbeam section group. So in order to change that, go in the view and selection option, select the intersection line, and select like that to choose only the crossbeam. So first unselect everything, select only the crossbeam, and assign the crossbeam to your model. Okay, now again come back in the load window, element, select the load case and the load group DLBC1. Here in the element, choose section 1. So here the section 1 only is selected. Then here, sorry, choose DLBC2, not 1, and use uniform load, global direction Z. So value will be relative, and 0, 1 for x2, and here you can enter the value of the load, so -38.96, and click on apply. Now we'll apply the uniform moment and torsion to the first part of the composite section on the left girder. So you can select it using the polygon tool, so which is here, directly like that. Then in the load type, select uniform moment and torsion. This time it will be in global X direction, and the value of M is 1.49. Click on apply. Now repeat the same procedure for the right girder. So select the element of the right girder first. Then you only have to change the sign here, so it will be minus, and click on apply. Let's activate again the boundary condition and the loads. Now we'll do the same for the DLBC3 and DLBC4. So just change that to DLBC3 first, then choose the left girder from here. First we'll assign the self weights, so it will be uniform. So select the section 2 and assign the value of the self weight and click on apply. Now we will assign the same moment, so uniform moment torsion. Don't forget to change to global X direction. Use the polygon tool to select the left girder only and enter the value, which is minus 1.5949. Now do the same for the right girder. Enter a minus sign and click on apply. Now change the load name, load case, and the group name. With the selection tool, select the section 3, click on add. In the load type, select uniform load, global Z direction, minus 38.96, click on apply. Select uniform moment and torsion, global X. Use the polygon tool for the selection. Click on apply. And finally, select the last girder here. Don't forget the minus sign. Okay, so now all the loads and the boundary condition are applied. Now we have to assign dead loads for the post composite section. So again, in the elements tab, we're still here. Select first select section, press the shift key and select the 3 section here and click on add. Now in the load case name, select DLAC, same for the load group. Choose uniform load in global Z direction, and for the value it will be minus 18.69 and click on apply. Now we'll apply same the uniform moment and torsion for global X. We'll use the polygon to select only the left girder, and for the value it will be minus 19.69. Click on apply. and we'll do the same for the right girder. This time the value will be plus 1969. Click on apply.